Hey there everyone. I'm going to go through a couple of the problems on this practice/review. Some of the more complicated. I won't hit every single problem, but I'll try to hit the ones that I expect you to have a little issue with. So let's take a look. So you've got three functions to work with here, f, g, and h. The first couple things they want you to do is to do some operations of functions. So add f and g together. So we can do that. We can also do g minus h, and finally g times f. So this is multiplication here, g times f of x. So I'm going to do number 2 with you, because subtraction can be a little sneaky tricky here. So g minus h of x we can think of as g of x minus h of x. And I really want to take care of all of g first before I subtract out h of x. So g is 3x. Okay, h is, and I'm going to plug in with parentheses here. I can do that here as well, but it's not as important. H is x squared plus 1. So just replace my g of x with 3x. That's what g is equal to. H of x is this up here, x squared plus 1. So this is what I have all together here. And again, it's important that when we plug in g of x, we plug in h of x, we do so with these parentheses, because that negative is going to distribute through. So we've got 3x minus x squared. We also have minus 1. Okay, so this is our answer here. This is what g minus h of x looks like. And it's fine this way, but we really should rearrange it. Standard form tells us to put the highest powers up front. So the x squared gets the first slot, then the x, and then finally the constant. Okay, so that's what g minus h of x looks like. As you're working through these, you can use Desmos to help check yourself, because since I won't cover every problem here. So for example, I've got g and h plugged in here through Desmos, and then I put in g of x minus h of x, which is what I was asked to solve. And so my answer I got was negative x squared plus 3x minus 1. So I'm just going to double check that my answer here matches this combination, right? This upside down parabola here. And this is looking pretty good, right? We have the negative x squared. So if we test it, we can see those are the same. Cool. So you're encouraged to use Desmos here to check your answers as well. You might note that Desmos does not like this notation, but if you put it in like this, it should work for all of these. Okay, let's take a look at another one. So number 4 here, we just have f and then this little negative 1. That means find the inverse of f. So how do I find f inverse? Well, you might remember we did this last week. So we start by writing out the function y equals 2x minus 1. And then what we're going to do to make this an inverse, we're going to swap x and y. So once we swap x and y, we now have the inverse function, but we should always write a function with the output by itself. So we swap x and y, right? And I just took our f function here, replaced f of x with y, and then swap out x and y. That gives us the inverse. Now we got to get y alone. So we should be able to do that. I've got this minus 1 I don't need, so I can add 1 to both sides. So x plus 1 is equal to 2y. If I divide everything by 2, I get y equals x plus 1 over 2. Okay, so that is my inverse function. So the only thing left to do is to write it properly with that function notation. So f inverse of x is x plus 1 over 2. Okay. Let's take a look at number 6. So number 6 is a composition like we've been practicing. So we want to put g inside of h. So start with your outside function. H is something squared plus 1. So I'm going to color code this. H is going to be my outside function. So that's take your input, square it, and then add 1. G, our inside function here, g of x, is just 3 times x, I think. Yeah. So for the input of h, I'm putting g, right? That whole function's my input. Okay, so this is my answer, but we can do a little better. We can clean this up algebraically. So 3x squared, that means 3x times itself, would give us 9x squared, and then the plus 1 is just going to hang out. Okay, so that's the composition of G inside of H. Okay, I'll leave some of these other ones for you. Number 7, this is going to be complex. We've got H inside of G inside of F, and then we actually have an input. We want to know, what is this when x is equal to 2? So you can create one big composition, one big equation that has H inside of G inside of F, or what you might want to do here is just do it piece by piece. All right, start out by figuring out what is H of 2. H of 2, we said H was input squared plus 1, I think. Yeah. So we start out with H of 2. So we plug 2 into H and see what we get. So that's 2 squared plus 1, that's 5. Okay, so when we say H of 2, we can think of that as just 5. So in other words, now we have what is F of G of 5. Then we can plug 5 into G, right? Do the next one out, plug 5 into G, see what we get, and then plug that into F. So you can kind of work your way from the inside out if you want to break it up and keep it less complicated. Or you can just write it all as one big function. Number 8, if you've been paying attention, should be super easy. No math involved. Okay, let's take a look at the back side of this. So this is what we learned last class, testing if two functions are inverses by composition. So we learned a rule last class that said if I plug one function inside the other and it just gives me x, plain x, nothing else, that means that they're inverses, that whatever has been done to the input by G is then undone by F, and we get that same input as our output, seemingly untouched. All right, so let's see what happens if we put F inside of, or G inside of F, and we'll find out if they're inverses or not. Okay, so F is 5 times an input minus 7. So I've taken out my x, right? Leave a hole where your x was. And then we're going to fill that hole, fill that input hole with all of G. So 1/5 x minus 7/5. Don't let the fractions scare you off here. It's really going to be quite simple when we multiply this out. Okay, so now we need to simplify and see, do we just have x here that looks more complicated, or is there more going on? So we can distribute this, and you might already see where this is going. 5 times 1/5, well, that would be 5 over 5, right? We just multiply straight across, so we get 5 over 5. So 5 times 1/5 x is just 1x, 5 over 5x, which is just 1. 5 times 7/5, we kind of have the same situation here. 5 times 7/5, we just end up with 7, right? Those 5s cancel each other out. Or if you do it the long way, you'll see you have 35 over 5, which simplifies down to 7. Okay, so we've got x minus 7, ooh, and then another minus 7. So we were really close to an inverse here. If only this was a plus 7, we'd just have the x left, but we don't. We ended up with x and some other garbage. So these functions are not inverses. Okay, f and g are not inverses. We don't really need to test it the other way around because we've discovered this didn't give us plain old x. If you're not sure of your answers, you can always do it the other way around as well. Find g of f, but I think we're safe to stop here. All right, try out 11. And again, what you're looking for, if they are inverses, then you should just get plain x, nothing else but x. If you get anything else like we got here, x minus 14, that tells us that these are not inverses. Okay, good luck with this. You guys can always reach out to me on Remind. Good luck getting through this, and we'll go back over it when I come back to class.